Hi, good afternoon. This is Yong Kee Sun. Welcome to another day of our submission. Today is milestone number 4. We're going to take you through some of the very important things. Uh, First thing is I would like to share with you how we going to clean the data and put all the data together for machine learning modeling. So we categorize our data to some white data, long data, and text data. What data is basically means is one row per day. Long data is multiple rows per day. That's because we are collecting multiple symbols for commodities, index, and forex. We, we have chosen the date range to filter 2nd March to 20th April because these are the only time range that we have most completed data set here. We will introduce a feature engineering, 3 particular columns, simple moving average of a 3 days window. We introduce as weekday, Monday to Friday. Saturday, Sunday will be dropped because it's not a trading day. And we will convert, with those sentiment analysis, we will create a new column called polarity to measure the quality of the business news title. Okay. We put everything into a big table by transforming, by joining, and eventually we're going to index our data set by the date because this is time series data set. I'm going to show you how we can clean the data using various methods here, and eventually you can scale, split, and model in the machine learning. Right, for preparing the data, first we have to transpose the long data. Long data, if you've seen here, this is NASDAQ and the Dow Jones Index, 2 rows per day. So we're going to transpose it to white, meaning 1 row per day with the values going to spread out throughout the columns. Right? So NASDAQ and Dow Jones spread out throughout the columns. And we're going to join the transpose white columns and white columns together into a final data set. So it's 1 row per day with all the business news, commodities, forex into respective features. Okay. Then we're going to deal with missing data. Missing data are caused by the data source itself is incomplete on certain days, certain values. So there are 3 techniques that I use here. First step is we're going to treat the intermediate missing data first. Intermediate, we use the nearest interpolation to the nearest neighbor. Meaning, for example, 5th March, you're going to get it from the nearest neighbor, which is the 4th March. You copy the value down. The 6th March, we're going to get it from the nearest neighbor, which is the 7th March. Then we're going to do the forward fill to treat the missing data at the last row. Right? Just simply going to copy from the last seen values. Same goes to the first row missing data, so you're going to copy it from the next seen value. Okay, I think that is a fair treatment to the data set that we have. Next, we're going to put in some additional features. As I mentioned earlier, I introduced a simple moving average of 3 days. 3 days because our data set is not very big, so I'm going to choose the past 3 days windows, average of the last closing price to be here. So the first 2 lines is going to be empty, so we're going to backfill it. The weekday, Monday to Friday, we're going to convert it into dummies, binary dummies, 1 being that particular day, 0 being not that particular day, right? So that is additional 5 features there. And for the sentiment analysis, business news title, we first translate from Chinese to English. Is pretty good translation here actually. And we will do a qualitative score, which we call it polarity. Positive values being is good news. Negative value means being is not so negative news. Right? The strength of 0 to 1 or 0 to -1 being how strong is that sentiment. We finally scaled all the numeric features to 0 and 1 using min-max. Okay, let's look at our goals of prediction. So the goal is really going to be benefiting the day traders, whereby their only interest of the price is going to go up or down tomorrow, because they're going to make the buy and sell decisions tomorrow, a bit for tomorrow. So if the price go up tomorrow, like 2.55 goes up to 2.66, then it's going to be true. If the price drop from 2.66 to the next day 2.54, so we are predicting it to go down, which is false. If the price has no change, it's false as well. Okay, so if we do this, the last observations is going to have a null label because tomorrow had not happened yet. So we're going to remove that from our data set. Let's look at the machine learning model and approach that we use. First, we split the data to 80 and 20. We really only have 36 data sets. So test set is only 7, training set is only 29 rows. And we do a baseline based on our training model first, right? Baseline is really just a naive way to predict that everything will go down tomorrow. Even that naive prediction will give us 57% accuracy. So we want to see whether our machines can beat these predictions or not. I've chosen XGBoost as our training algorithm, machine learning algorithm with default parameters. First run of the machine learning models, we have a training set accuracy 81%, 42%, 86% on the testing set. So it's not very good, right? Maybe a bit overtrained. And XGBoost, one of the features that XGBoost gives us is it tells us which features are important, right? So based on this table, I pick out of the 46 features, I pick just a handful of them, right, based on this table, into our next fine-tune model. So I also regularize the gamma values to regularize the models from the value of 0 to 5. So the model is less complex. And with less features, is still able to give us 42 actually the same test performance, but the reduced training performance, right? But the model is much more simplified with less features and with regularization in place. So next, we want to see whether this prediction is of any good or not, right? Does it help the day traders to make some money? So let's look at this training set. I've hidden the test set, right? So let's look at the training set. Those highlighted in green boxes are the exciting part, where the machine has predicted that the price is going to go up tomorrow, and it did go up, right? The green boxes, and it looks exciting. The cross dots are the wrong prediction, right? These are the false negative, meaning machine predicted that it goes down, but in fact it went up. The price went up next day. So that is fine, because if the price is predict is going to go down tomorrow, we didn't invest, so there's no loss incurred for the false negative. But what we are more interested in is the true positive rate here. Right. Now let's unveil the test data. Unfortunately, the false positive the machine is not able to predict any true positive, right? So because the whole time series is towards a downward trend, I guess there's a reason why the machines predicted downward trend for all the test data, right? And hopefully the next day it will predict that price go up, and it actually went up, right? So we don't know yet, right? So it doesn't have the day trader for now, but at least it doesn't incur any loss. But what I'll be more interested in is to explore another machine learning method, I will call it. I call it progressive modeling, whereby we fix the training windows and we predict only one data set, only one observations next business day, and we shift the models. We retrain the model, and we predict another next day, and we retrain the model based on the fixed window size, and retrain the next day, right? And we shall see whether using this technique, by going through all the test data sets here, whether we can give a better true positive prediction based on our compared to our previous traditional machine learning method. All right. So that's all for today. Hopefully, I have time to do this. Thank you so much.